Okay, it seems that our first effort didn't have any sound, so I'm redoing this. This is section 1.5 for the flipped classroom for AP Calculus. Session number 11 on tangent lines. This is the last session in this chapter, so your test will probably be the class after next. Here we go. What is a tangent line? Many people think that a tangent line is where the graph or the line just touches the graph in only one place. And although that is one way to think of a tangent line, a line can cross a graph in more than one point and still be tangent in a certain interval. We'll see in the next slide how that can happen. Here we've got a curve that is in red, and we have the tangent line. At one point on the left, the line is tangent. On the other, it is not, even though it crosses the graph. It can cross the graph in more than one place. It touches the graph in more than one place. Another way to think of tangent lines, remember way back when we talked about secant lines to a curve. And we asked, what happens when the difference of the x-coordinates approaches 0? In other words, delta x, that would be the difference of the x-coordinates, approaches 0. The next slide will refresh your memory. Okay, here's the curve in blue, the secant line is red, and the tangent line is black. As I move P towards Q, okay, you have to ask yourself, what happens to the slope of the secant line? Because new secant lines are formed continuously. Okay, if I move P close enough to Q, the difference of the x-coordinates, x2 minus x1, where x1 is the coordinate for Q and x2 is the coordinate for P, that difference becomes very small. We would say delta x approaches 0. And we can take the limit, okay, of the slope of the secant line as delta x approaches 0. And we would call that limit, if it exists, the slope of the tangent line. It's very important because the slope of the tangent line at this curve gives us a measure of the instantaneous rate of change of the function. Here's the sample problem. Okay, we have the graph of y equals x squared. I've drawn the 2 points P and Q. The corresponding coordinates in terms of x would be x subscript 2, f of x subscript 2, and at Q it would be x1, f of x subscript 1. Notice I also have the x coordinates listed on the x-axis there. Delta x would be x2 minus x1. The slope of the secant line PQ can be expressed as f of x2 minus f of x1. x2 minus x1 would be the denominator. Okay, as delta x gets close to 0, this slope becomes the slope of the tangent line at point Q. We can express this as the limit as delta x goes to 0 of f of x plus delta x. That's really just f of x2, I'm just expressing it in terms of x1 and adding the delta x, minus f of x, all over delta x. That will be our definition for the slope of the tangent. For f of x equals x squared, here's the limit definition again. Delta x goes to 0, f of x plus delta x minus f of x over delta x. This notation is a little different than what we used before. We used h for delta x. It doesn't matter. So let's just substitute in using the function. We would get x plus delta x quantity squared minus x squared in the numerator. The denominator is incorrect. It shouldn't be x squared. It should be delta x. If you look to the right of the equal sign, I've expanded that numerator. I've FOILed out the binomial expression. You get x squared plus 2x delta x plus x squared minus x squared over delta x. Take the limit of that and you will see that you get, as delta x goes to 0, you will get just plain 2x. That expression represents the slope of the tangent to any point on the graph of y equals x squared. So let's just say x is 2. Then the point that we're interested on the curve would be 2, 4, because 2 squared would be 4, and the slope, 2 times 2 would be 4. So the slope of the tangent at the point 2, 4 on the curve y equals x squared would be 4. I can get an equation from the tangent line because now I have a point they share in common. 2, 4, and I have the slope. Okay, setting it up in the definition of slope, I get 4 equals the difference of the y's over the difference of the x's, and I end up with y equals 4x minus 4. Okay, what about vertical and horizontal tangents? Well, we would say a graph has a horizontal tangent when the slope of the tangent line is 0. Remember, a horizontal line has a 0 slope. Graph has a vertical tangent when the slope of the tangent line is infinite. An example of this is after you take the limit using our limit of the slope of the secant line, you get, let's say you get the expression 1 over x. We would say there's a vertical tangent at x equals 0 because the limit of that would approach infinity as long as, and this is important, x equals 0 is in the domain of the original function you started with. If it's not in the domain, then you can't have a tangent there because there is no point. Okay, here's an example of a type of homework problem you might find. Find the slope of the function's graph at the given point and find the equation for the tangent. Okay, g of u equals u over u minus 2 at the point 3, 3. So we have the limit definition, delta u goes to 0, f of u plus delta u minus f of u over delta u. We're just using u instead of x. The limit, okay, what I've done now is I've substituted u plus delta u into the function. I get u plus delta u over u plus delta u minus 2 minus u over u minus 2. Let's find a common denominator for the numerator. That common denominator would give us u plus delta u times u minus 2 minus u times the quantity u plus delta u minus 2 all over the quantity u plus delta u minus 2 times the quantity u minus 2 times delta u. Okay, let's FOIL out the numerator. Okay, this is a long numerator. You get u squared plus u delta u minus 2u minus 2 delta u minus u squared minus u delta u plus 2u. That can be simplified quite a bit. The denominator remains exactly the same. Don't mess with the denominator. Okay, after I simplify the numerator, I actually get negative 2 delta u. The denominator stays the same, u plus delta u minus 2 times the quantity u minus 2 times delta u. You can see I can cancel the delta u's because delta u over delta u, as long as u doesn't equal 0, it approaches 0, is simply 1. So taking the limit, since there are no delta u terms left, the limit is simply negative 2 times the quantity u minus 2 quantity squared. Okay, now if I want to know what the actual slope is of the tangent line, substitute our point. X equals 3. I have negative 2 over 3 minus 2 quantity squared is negative 2. So at the point 3, 3, for that original function, the slope of the tangent line is negative 2. And then just using simple algebra, set the slope equal to the difference of the y's over the difference of the x's, and you wind up with slope-intercept form, y equals negative 2x plus 9. That would be the equation to the tangent line at the point 3, 3. Pretty cool. Here's your practice problems for tomorrow. There will be an Edmodo quiz, pages 139 to 140, numbers 1 through 26. Have a good evening.